In this lecture, I'm going to introduce you to the concept of a context-free grammar, which has more power to describe languages when compared to finite automata and regular expressions. After learning about context-free grammars, you would see that they are capable of generating all the regular languages and some non-regular languages, but not all of them. The collection of languages associated with context-free grammars are called context-free languages. If you heard what I said earlier keenly, I used the word generate instead of recognize. You heard it correct. Context-free grammars are used to generate languages, whereas DFAs and NFAs recognize languages. Let me start this topic with this example. Here I have statements which are capable of generating strings that follow a specific pattern. These statements are called production rules. The production rules contain variables and terminals. The variables can map to other variables, terminals, or both of them. The terminals are typically the characters from the alphabet of the language. The production rules have a designated start variable. It usually occurs on the left-hand side of the topmost rule. Now let's see how these production rules generate the string 000#111. A can generate 0A1. We can repeat the same 2 more times, after which we can use the second production rule to arrive at B. And finally, the third production rule to generate the required string. The sequence of substitutions to obtain a string is called a derivation. We can visualize this derivation as a parse tree as well. In this tree, the root will always be the starting variable, and the leaves are always terminals, which are characters from the alphabet, and all the intermediate nodes are variables. If you observe closely, there is a recursive structure to the strings generated by context-free grammars. If you enumerate all the strings that can possibly be generated by this context-free grammar, you would end up with this language description. You would have already noticed that the variable B here is unnecessary, as I could have simply written A generates the terminal hash. Fair enough. I just had it up there for demonstration purpose. These 3 rules can be abbreviated this way. You can read this as A generates 0A1 or B, and B generates hash. Alright, would you like to see the production rules for the language 0 to the power n, 1 to the power n? There you go. With these 2 rules and 3 terminals, you would be able to generate the strings from this language, which could not be recognized by any finite automaton. The recursive structure of CFG allows us to achieve this. You would be surprised with what you could potentially achieve with context-free grammars. You can generate sentences in everyday languages if you identify the inherent production rules, variables, and terminals, which are basically words in that particular language. CFGs are also used in designing compilers for programming languages. We shall look into the formal definition of CFG in the next lecture.